with me with the time in India.
I didn't know that at all. I had no idea it was 1.5 hours. I thought we could only have whole hours.
No, you can have half an hour.
Oh, wow. Interesting. I didn't realize that.
We have 5.5 hours off GMT, actually.
Oh, I see. I see. Interesting. Thank you.
Dr. Basil.
Good evening, everyone. Can you hear me?
Yeah. Welcome, Dr. Basil.
Thank you so much.
Dr. Basil Kadura, from where?
Yes, I'm Basil Kadura. I'm from Palestine, lived in Syria, but I'm practicing in Sweden now.
Sweden. Oh, fascinating. In which city are you in Sweden?
It's the West Sweden, you know, Gothenburg.
Gothenburg. Okay, lovely. Yeah,
Yes.
Excellent. Good,
Just
good.
a town over Gothenburg, Uddevalla. It's about 1 hour driving, something like
Oh,
that.
nice. Good, good. Excellent. Oh, nice to meet you.
Me too.
Yes.
Sorry, I was a little bit late, but I have some patients, acute patients to deal with. Now I'm clear anyway.
So what time is it in Sweden at the moment?
Now it's about 5 p.m.
5 p.m. Okay, so 2 hours behind Abu Dhabi. Okay, fine.
6. I think it's the time now.
Time is 7 now. Dr. Ronald, Dr. Rahul, there's the moderator to start, please. Can we start the session?
Yeah, I think we can start.
Yes, please. Yes, please.
Yeah.
Are we broadcasting now? Are we broadcasting live?
Yes, we are. We should broadcast Facebook.
Sorry, I mean, can the attendees, can they now see us?
Yeah. It's already, yes. We already have the attendees and you can see them. Yes, it's already.
Oh, okay, good.
So I think.
Yeah, I think that it says there are 77 people who are logged in. So I certainly think we can start. They'll all be eagerly anticipating our talks.
Because this is the time will end sharp this year. We didn't have time to lose.
That's absolutely well said. Well said.
Yeah. This is 90% now.
Okay.
So who is the first speaker? I'm not sure who's the first on the program.
Dr. Ali, isn't it?
Yeah, for me, the first speaker, I will make the introduction for visual field. I will share my screen.
Great, thank you.
Yeah. Are you seeing my screen?
Yes.
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 It's a problem here only two. Yeah. To this here now. Okay.
Yeah,
Are you seeing my screen?
Yeah, it's clear.
Yeah.
Okay.
Yeah, thank you for all. It's nice to meet you here in this course, visual field course. This is now my presentation as introduction to visual field and kinetic versus static visual field. This is my agenda. We know that the definition for visual field is the classical description of the visual field given by Tracker as an island hell of vision in a sea of darkness. The normal island of vision, we know this is the highest sensitivity is in the point of fixation is the fovea. On the highest of the hell of vision decline toward the periphery as visual sensitivity diminish. There is absolute depression correspond to a blind spot. The normal visual field is around 60 degrees superiorly and 75 degrees inferiorly, and also 60 degrees nasally and to 90 to 100 to the temporal side. For this island, topography of this island can characterize by two ways, kinetic perimetry or static perimetry. Now we describe about kinetic perimetry. In the kinetic perimetry, the stimulus move from non-seeing area to the seeing area. And this is usually over the meridian, usually in space every 15 degrees. But in kinetic perimetry, only one attempt to find the location in the visual field of equal sensitivity, equal retinal sensitivity. Connection for this point make an isopter. If we need another isopter horizontally, can we change the luminance and the size of the target? Here we see this is movement of the target from periphery to the center. When we see, can make a mark, and after that we make connection to have an isopter. If we another isopter, we change the luminance on the size, we can have more isopter, and this is we can measure the perimetry as horizontally. We see this is here. Every isopter has this is many number here, and in the kinetic perimetry, as there is a slice of different elevation. This can be done by manually or Goldman perimeter. But manually only, this is for the rough visual field, only when we thought there is a heminopia or something, but more accurate with the Goldman perimeter. For the frontal visual field, here the examiner on the patient sitting in a distance from 1 meter in the same level, and after that ask the patient to close the one eye, for example left eye gently, and look with the right eye to the left eye for the examiner, and after that the examiner in halfway elevated the hand and asks the patient to see how many fingers. And this is here a small trick, only ask the patient 1 to 5 fingers, not to ask 3, 4, and after that is more easy to ask 1 to 5 fingers, and after that we make test for all the 4 visual field quadrant. But the more accurate for the kinetic perimetry is the Goldman perimeter. And the Goldman perimeter is calibrated as Paul projection instrument with background intensity of 31.5 upstil. And this is in the range of photopic range. But now with the new machine, for example, with OCTOPUS perimetry, this is here the static and the kinetic in the same machine. Now, when we see this is any isopter for the Goldman perimeter, the stimulus used to plot an isopter are identified by Roman numeral, Arabic number, and letter. The Roman numeral represent the size of the object from Goldman size 0 to 5, and the Arabic numeral represent 5 decibel of attenuation, and the letter is from 1 decibel attenuation. If we look here, look down, this is for the old machine, and now the left down, this is from the new machine. If we look here, that darkest stimulus from 1A, 19 decibel, to brightest stimulus, this is 4E, this is around from 19 decibel to 0 decibel. If we look, this is here for each size increment equal, 2-fold increase in diameter and 4-fold increase in area. But please look here, this is for the old machine on the left side, on the new machine on the right side. This is not the same. This is only from the old machine, there is the size from 0 to 5, but the new machine only from 1 to 5. The diameter also different from also the area. For that also, we cannot compare the same kinetic perimeter from different machine. The usual size is the 5 4E, 3 4E, 1 4E, and then dimmer more 1 2E, and etc. Usually, this is that size is a 3 is the same as used in the standard static perimetry. But the larger, we use that for low vision defect. And for the smaller, this is for the smaller area on high resolution. There is the comparison between OCTOPUS kinetic perimetry and the Goldman kinetic perimetry. If we look here, the old Goldman kinetic perimetry, this is totally manual stimulus presentation, but by the OCTOPUS, this is computer controlled. But as the design is the same for the background illumination. The difference in the stimulus type, In the OCTOPUS kinetic, the Goldman size from 1 to 5, but for the old GOLDMAN kinetic from 0 to 5. Also, this is from the speed can only manually by GOLDMAN kinetic and can manually by the OCTOPUS kinetic, or that's fixed by the computer movement, the stimulus from 1 to 10 degrees per second. The individualization and automation, all this is for the old GOLDMAN, that's full individualization. By the new one, can this combination with full automation. This is here for the isopter. If we look here for this isopter, when we test on the from periphery to the center, we make this line for the isopter, but we should go through that and test the area inside the isopter, because this is area inside the isopter is higher sensitivity and should be seen from the patient. But if the patient cannot see, perhaps there is a focal visual field defect. For that, we should mention about this area is tested or not. This is the same with the new machine. When we make this here the isopter, and we find this area is cannot see, make this here the stimulus perpendicular to the horizontal and vertical to make, as in this patient with superior nasal visual field defect. And when we movement, and we find there is point cannot see from the patient, can move from this point in all direction to know how is the size for this visual field defect. As to compare with the static perimetry, here the size and the location of the target remain constant. Only here this is varying in the brightness of the stimulus, and the shape of the island is defined by repeating the threshold measurement at various locations in the field of vision. We know this is, as mentioned, we measure the visual field with the kinetic horizontally, but here in static we measure the visual field vertically. And the most common machine is the Humphrey and OCTOPUS. In this visual field, we usually need the threshold. The threshold is determined as an intensity of light that's seen 50% of the time, and this is measured in decibel. The 1 decibel is 1 of 10 of logarithm unit, and the light presentation should be less than 0.5 seconds. If longer stimulus presentation can lead to temporal summation of the retina. For that, usually only this is less than 0.25 seconds. The most is the famous from this static perimetry is the white target on white background is the same as achromatic standard automatic perimetry. On the advantage here, standardized examination strategy. But this is, we can compare any examination with the same machine or from the same machine, but here Humphrey or OCTOPUS. We cannot compare Humphrey with OCTOPUS. We see now. This is the advantage of static automatic perimetry. We eliminate perimetrist variability, but we cannot eliminate the patient variability. This is here many form of Humphrey or OCTOPUS, no financial interest. Here for both machine, the background luminance is the same, it's 31.5 apostolic. But if we look how much the maximum brightness is for 0 decibel in Humphrey is 10,000 apostolic. But this is not available in OCTOPUS. In OCTOPUS, the highest the brightness is 1,000 apostolic is 0 decibel, but this is 10 in Humphrey. For that, we cannot compare visual field from OCTOPUS with Humphrey, but Humphrey with any type of Humphrey can we compare the visual field. If we compare, this is the static and kinetic perimetry. The fixation number of predetermined location is static, but this is individually adjustable moving target and is kinetic. And static is full automated, but in kinetic, this is automated or full automated, all this by the only manually. The advantage of kinetic perimetry is very high spatial resolution. If we look for this patient with advanced retinitis pigmentosa, Look here at the visual field defect as seen by the kinetic perimetry. You can see there is tuple vision with remnant of the visual field at the periphery. You can see very clearly on the visual field need around 7 minutes. But if we look here at the static perimetry, you cannot see how much as clear as the kinetic perimetry on need at least 15 minutes to take this result. But still the static is more accurate because we depend on the threshold, the sensitivity threshold for each point for the patient, on the slower sensitivity in the kinetic. For depend on that, we can know that the static is more better for small changes in the sensitivity and the changes in the central 30-degree, and compared to the kinetic is good for small changes in the spatial extent, changes in the periphery or remaining visual field in advance or defect in children. That's a better indication for static is in glaucoma, macular disease, visual ability testing, but still for kinetic in neuro-ophthalmology cases, peripheral retinal disease, low vision and children, also there is still indication for that. As for small point for in glaucoma, always we recommend in glaucoma as static threshold perimetry. If we have very advanced disease, can we use the size for target 5 or we 10-2 to see enlarge the defect in the macular area? But sometimes can we use the GOLDMAN visual field when that's available in very old or in child or if unable to do automatic visual field. As a summary, accuracy and indication are more for static perimetry, but still there are an indication for kinetic perimetry. Thank you. This is my introduction.
Thank you very much, Dr. Ali. That was a very comprehensive introduction, and I'm glad you stuck to time of 15 minutes. We now have Dr. Hassan Khalid, who's going to also do a presentation also about visual fields. Thank you very much, Dr. Hassan.
Okay, thank you. I will share my presentation. Okay. Okay, thank you. I'm going to talk rapidly about how to read the visual field. I don't have financial interest. My talk will be about how to read the single field analysis. As you can see, this is a Humphrey machine single field analysis. You can see the patient data here and the site of the eye. So you can see the field program here. The reliability indices, also you can see the sensitivity numerical map, grayscale map, and total deviation map, and pattern deviation map, total deviation plot map, along with the pattern deviation plot map, along with glaucoma hemifield and global indices. Also, I will talk about the gaze tracker and the probability. It's very important to write the date of the patient, date of the birth of the patient, because the machine will compare with age-matched control. Also, you can see the age can be present in this side. The fixation monitor, there are the machine using the gaze tracker with the blind spot for the monitoring the fixation of the patient, as it presents the stimulus at the blind spot. If the patient presses the button, that means the patient is not fixating on the central target, and it looks, sorry. Okay. Okay. And to know that we look at the fixation losses value, I will talk about the gaze tracker in the end of my presentation. Here, the fixating target can be central, which is yellow light in the center of the bowel, or small diamond. It's located below the central target used in macular degeneration. And it can be large diamond for patients with central scotoma, or bottom LED test that require a lower fixation light than as central target. Hello? Is it clear? Yeah.
Yes, it's clear.
Yeah, good. Okay, I will also we have to look at the reliability indices, the fixation losses and false positive error and false negative error. And these reliability indices for fixation losses, seeing the stimulus when it's projected at the blind spot, and that should be less than 25%, and the false positive error when the patient responding to the machine sounds and not responding to the stimulus, which is trigger happy, it's up to 15% acceptable. And when the false negative error, that means the patient responding to the stimulus at lower sensitivity and ignoring it in higher sensitivity at the same test point location, and that should be accepted up to 15%. When it's higher, that means the patient is inattentive or patient may be tired. Sometimes the high false negative can result from tested points showed wide variability in patient with deteriorated visual field. For example, we can see here 411XX. What that means? That means that the machine presents the stimulus at the blind spot 11 times, and the patient presses the button 4 times. That means 4 from 11, which is more than 25%, and that the test is unreliable. Also, here you can see the test duration and the fovea. You can make it on, off. You can see the sensitivity at the fovea if it's on the machine. Stimulus size, as Dr. Ali said before, we have that size from 0 up to 5 in the automated, and the color is white, and the background is 31.5 still the intensity. As you can see here also the size from 0 to 5, you can see the comparing the size of 3, which is the standard, with the blind spot, and you can see the size of the 5. As Dr. I said, the size 5 can be used in advanced glaucoma in case to know the status of the macular split. And the color of the stimulus is bright white, which is projected against the pale white of the background, which is about 31.5 abostilb intensity. Here you can see the program that used in the visual field. You can see we have many programs. It depends on the total points of tested points in 32, 24, 2, 10, 2 macular. Also the field, which is 30 degree or 24, 10, 5 degrees. Oh, and the 2-point apartment and pair area, which is different from program to program. As you can see here, 10 to program, it's only the 10 central point of the 32 programs. Here you can see also what the mean of 3-degree pair area, which is a distance between the line between 2 points and between the center, and what is the apart between 2 tested points is about 6 degrees. Also, the strategies is very important to know what strategy that your machine is using. The gold standard strategy now is CETA standard, not CETA fast. There are before threshold strategy and supra threshold strategy. Supra threshold strategy is consuming less time, so it was used for screening. However, the threshold, it's more accurate and consuming more time. For the threshold test strategy, the old standard one, it was full threshold. However, these days, the old standard one, the gold standard one is CETA standard. The CETA standard, it's using the bracketing strategy, and it's reducing the time comparing with the full threshold 50%. It can use 5 minutes for the normal patient and 8 minutes for the glaucoma patient, and the sensitivity of this CETA standard is similar to that of the full thresholds, 95%. However, CETA fast is faster than the CETA standard, but it is less or lower sensitivity than the CETA standard. It's only 93%, and the time that used in CETA fast is 3 in normal 3 minutes, and in glaucoma patient 6 minutes. So the gold one is the CETA standard. The pupil diameter also is very important, as the diameter of the pupil will affect the main deviation and can lead to main deviation significantly reduction or constriction of the field of the vision when the pupil is less than 2.5 millimeter, or when it's more than 6.5 millimeter. Also, when it's more than 6.5 millimeter, it will affect it will increase the pattern standard deviation significantly, also will depress the fovea threshold. So the ideal diameter between 2.5 up to 6.5 millimeters. We can see here also the refraction for this patient. Patient may need to use correcting near vision, which is a crucial step in the visual field testing. Also, in case if there is no correcting, that will lead to generalized constriction of the visual field, and it will present on the mean deviation value. Here we shift to sensitivity numerical map and the grayscale map. The sensitivity numerical map, it is the measurement, the sensitivity, the threshold measurement of each test points in this patient. As you can see, when the number is high, like here 31 and 32 in the red circle, that means the higher sensitivity. These points need lower intensity stimulus to be stimulated. However, when it's in the periphery like this one, 27 and 23 decibel, that means this is with lower sensitivity points that need higher intensity stimulus to stimulate these points. This is the numerical map. This is the grayscale map. Also, the lighter regions indicate to higher sensitivity and darker regions indicates to the lower sensitivity. We go to total deviation numerical map and pattern deviation numerical map. The total deviation numerical map, it is the decibel deviation of the measured threshold values for the patient comparing with the age-matched control, and average of all these points will give us the mean deviation. And it is the same for the pattern deviation, but after adjustment of the measured threshold value for the patient will give us the pattern deviation. Let us say that the gray line, the green line, it is the normal database for the same age of the patient, and the red dots, it is the measurement for the patient, threshold measurement of the patient. It's present on the sensitivity numerical map. And the difference between these, the red arrows, between these red dots and between this green line is the total deviation. And the average of all these numbers are the mean deviation. Also, the same for the numerical pattern deviation map, but here let's say that the threshold value is the green dots, but after adjustment, this is measured values, the red dots, and the difference between these red dots and between the normal age give us the pattern deviation numerical map. Here we're going to talk about the total deviation plot map and a pattern deviation plot map, which is very important to look at these maps while reading the visual field. First, let's say what is the probability. It is a measure of a chance of getting some outcome of interest for some event. So the chance that something will happen, this is the probability. We can see here the probability for dots. That's the probability to be normal less than 5%, and this is light shaded box, the probability less than 2% to be normal. This is moderate dark shaded box, the probability to be less than 1% to be normal. When there is a black shaded box, that's the probability for this point to be normal is less than 0.5%. For example, here total deviation map, you can see in this map, we look at the size and the shape and location of the defect of abnormal points and the boxes. And when there is generalized depression, we can see a lot of shaded boxes in this deviation map, like in case of cataract or in case of meiosis or dilated pupil. The darkly shaded boxes uniformly filling the grid of the total deviation map in case of cataract and meiosis. However, in some cases, when there is generalized depression, some local defect may be hidden because of this generalized depression of the total deviation. Going to the pattern deviation plot map, which is a very important, this map should be carefully inspected for early detection of a glaucoma or for progression of a glaucoma visual field defect. So each test location is graded as normal or abnormal at a defined level p-value compared to normative database of this pattern deviation. When the lower p-value, the greater its clinical significance and the lesser likelihood that defect having occurred by chance. Let's say this is a defect in this pattern deviation map. The scotoma is the moderate shaded box when the p-value is less than 1%. That's mean this point, it's abnormal, but it can be normal in less than 1% and so on. So the gaze tracker chart also can use in the prediction. It can use also as a visual field reliable test through the prediction of the over or underestimation of the result of the visual field. And it is monitoring the gaze position at each stimulus presentation, the frequency of the eye movement per stimulus. The upward bar, you can see the upward, that's mean the fixation disparity, and the lens, that's mean the representing the magnitude of disparity from 1 degree up to 10 degrees. And the short downward, you can see sometimes downward bar representing the tracking failure, and long downward, the short one, tracking failure. The long one is the blinking failure, blinking of the patient during the test, or sometimes due to the dryness of the patient because of the film breakup in front of the eye. So you can see here also, it is found by a lot of study that the high values of the movement when the movement during the stimulation of this point, the gaze flicker or gaze tracker during this is test between 3 degrees to 5 degrees, or the movement more than 6 degrees. And in case if there is a tracker failure, or case of there is a blinking during the test, that all of them lead to lower the mean deviation and lead to generalized depression in the visual field. So the important indices of the visual field, which is a glaucoma hemifield test, and mean deviation and bad standard deviation. So I will talk about this. Global indices, the mean deviation, it is the average, as I said before, the average of the decibel deviations of the measured threshold values from the normal age matched values. It's give us the height of the field, and the average of all these numbers give us the mean deviation. It's normal between -2 up to +2 decibel. And the beta standard deviation, it is give us the shape or the irregularity of the visual field, and also indicates to local defect in visual field, sometimes may be hidden by generalized depression of the visual field. So in case if the beta standard deviation is high, that's indicates to deep or local defects. But when the beta standard deviation is low, that indicates maybe normal or maybe severely damaged visual field. I don't know if I have time.
Thank you, Dr. Hassan. I think maybe you ought to give over to the next speaker, if you could just summarize, please.
Okay. Okay. So can I continue, or for an
please do a quick summary, and then we'll continue to the next speaker, please.
Yeah, okay. So this is the beta deviation, short-term fluctuation also. It's measured by the full threshold, but not represented by the theta. The corrected beta standard deviation also is measured by the full threshold, not represented by the theta. And the visual field index, which is more more accurate than the mean deviation, and not affected by the cataract, and more concentrated to the ganglion cells. Here also the glaucoma hemifield test, which is very important while reading the visual field single print out of the patient. It can be presented by normal or outside normal or borderline or generalized reduction. While reading, it's very important to check the quality or reliability of the visual field test, then to assess the normality or abnormality, then you can identify the artifacts. I will go quickly, just 1 minute or 2 minutes. The reliability indices, as I said before, then we can look at the total deviation, the blot map and pattern diffusion.
Okay, thank you, Dr. Hassan.
One minute, only 1 minute. This is a very important thing. Okay, only 1 minute. So assessing the normality or abnormality to know if this visual field is normal or abnormal regarding to the ocular hypertension studies, it's found that when the better standard deviation less than 5% or presence of a glaucoma field test outside normal in 3 consecutive visual field tests, the test is abnormal. Also, Anderson criteria is found by there is a glaucoma field test is outside normal limit 3.98 breast p-value less than 5%, one of them is less than 1% in pattern deviation blot map with corrected pattern standard deviation, when the probability is less than 5%, all in 2 consecutive. But this one in full threshold, however, there is a modified Anderson, which is just replaced the corrected pattern standard deviation with the pattern standard deviation in 24-2 program CETA standard in 2 consecutive test. This is the criteria to detect the glaucoma and to know if your visual field is glaucoma or not. And thank you. I'm sorry for. Thank you.
Thank you very much, Dr. Hassan. That was very interesting. That was very good on the detail. Very good. Thank you. We will now move on to Dr. Ronnie George, who is joining us from India. I'm grateful to have him with us on the team today. He's going to talk about artifacts on visual field, as far as I understand. Thank you, Dr. George.
Thank you, James. Dr. Hassan, could you stop sharing your screen, please? I can't.
Yeah. Sorry. Okay. It's okay. It's okay now.
Thank you.
Okay, thank you.
Yeah. So can you see my slides?
Yeah.
Okay, so these are my financial disclosures, none related to the talk. So I'll basically talk to you about artifacts on visual fields, and they can happen because of 2 reasons. One being improper test administration. The second is patient related, and I'll give you a few examples of each. So improper test administration can happen just because of the way you position the patient or the corrective lenses that you use. For example, if you look at these 2 examples here, you can see that in the example on the left of the screen, the degree of field subtended is much smaller than the example on the right, because the lens, the correcting lens, is placed further away from the eye. What happens in clinical practice is that a well-centered field could look like this, and this is an absolutely normal patient who can give you a field which looks like this. And this is the sort of artifact that you can get because the person's forehead is not touching the address there. And this is the sort of field that will be produced by this sort of patient position. And it can mimic a glaucomatous field. It can look like that. And unless your technician has been obsessive about patient position, this can be a problem. Some versions of the machine will actually give you a beep if the forehead is not touching there, but not all versions will do that. The other thing that you need to look for is lens rim artifacts. And lens rim artifacts are related to the correcting lens that you have used. Again, if the position of the head is slightly off, you can get this sort of an artifact. And this is basically an example that I'm giving where it looks like a superior aqueous defect, but it's actually related to a lens rim. And they can be subtle. For example, you look like this, this 30-2, you might actually think that these are just artifacts, so these are really not important. And this is an otherwise normal looking field. And this is a lens rim artifact, again related to the lens rim. It can also be related to the correction lens that you have used. And the corrective lens, for example, you see a field defect like this, very dense defects, all 0 all around, nothing much else in the center. And this is because they have not used a full field lens, they've used a trial frame lens. If you use a trial frame lens, you can get this type of an artifact, and you have to ensure that your perimetrist does not do that. You need to use full aperture lenses for this. I'll talk to you basically, this is another type of lens rim artifact that you can get when you have a cylindrical power that you want to correct. And you don't use an appropriate lens, you can see this sort of a defect. This is something we described a while back. So if you use a frosted lens to correct a visual field, to correct a cylindrical error, you can see this type of an error on the field test. So you have to use full aperture lenses which are not frosted, and you should make sure that they are not even used by accident, because the same field which looks like this is absolutely normal once you use an appropriate lens. The other thing that can influence your result is if your pupil size is not monitored. Dr. Hassan had alluded to it, and this is a patient who has done the visual field with a pupil which is suboptimal of 2.1 millimeters. And you can see that when you repeat the visual field with an appropriately sized pupil, that really dense biaquate defect becomes much less. You also need to look for refractive errors that can impact perimetry, and they impact perimetry because of the type of corrective lens that you use. So I'm showing you two examples here. Now this is somebody who's showing you some inferior aqueous defects there, and you can see that, and look at the corrective lens used. It's a plus 7.25 diopter lens. So with the plus 7.25 diopter lens, what you can get is edge artifacts because of the prismatic effect of the periphery of the lens. Once you do the same test with a contact lens, and you can see that test is done with a contact lens there, you're seeing an absolutely normal field. So for high refractive errors, you should use an appropriate correction factor. And this is true for both plus and minus lenses. So this is somebody who's done the test with a contact lens, and you can see that they've just overcorrected with a +1 on top of that. Well, the actual power is a minus 14 diopter error. And here you can see that this field looks quite different from this field, and this is because of an inappropriate correction being used. You also have to make sure that a proper fixation target is used. And this becomes important because let's take a look at this field. Now this is somebody with fixation losses of 100% over there. And the field, the machine of course flags it as being unreliable and tells you that the glaucoma hemifield test is outside normal limits. But it doesn't give you any information about what the patient actually would do. So when you repeat the field and you find it's a little with a large diamond, and this is because this patient, look at his foveal threshold, it's 17 decibels. His visual acuity is 3/60 or 6/120. So this is not somebody who will be able to fixate on a central light and therefore will have trouble fixating. And when you should be using something like this, which is a large diamond or a small diamond for fixation, and instead of the central fixation, whenever the visual acuity is very low or when you have a central macular disease. The second issues that you get are patient related, which are related to inadequate instruction or comprehension by the patient. And this is something which you again have to monitor, and is much more common when they are doing the visual field for the first time. So this is the type of white patches on the gray scale that you see. And these white patches are typically flagged as abnormally high sensitivity. And they happen typically like this: fixation losses, these white patches, and abnormally high sensitivity. And just look at those threshold values. This threshold value is 50 over here, and you're seeing a field which is almost white over there with just a few brown spots. The MD is plus 16.53, which is much, much more than what you would expect to see in anybody. You expect to see minus values and not plus values. And the false positive rate is 70%, fixation losses are 100%, because this person has been moving the gaze to look at the stimulus and try and press it, and also pressing basically every stimulus that is shown. It is physiologically impossible to get a threshold of 50 decibels in the periphery when your foveal threshold is 32 decibels. This is another example that I'm showing to you over here. And here you need to look at, again, a high plus MD value, high fixation losses, high false positive errors, all very, very typical of the so-called white scotomas that you're seeing here. The second pattern that is fairly common again is what is the cloverleaf pattern. And this is this occurs because whenever you do a visual field test, the first 4 points to be tested are here: 1, 2, 3, and 4. And these 4 points, based on this, the rest of the points are tested. So this is somebody who paid a little bit of attention towards the beginning of the test, did these bits okay, and then after that sort of lost attention, and you get this typical cloverleaf. And if you have a so this is somebody who did 99% false negatives, very bad mean deviation, and you can see just those early and incomplete clover where the person did some sort of testing. You repeat the testing, looks a little better, the clover looks a little larger. You repeat it again, and it comes down to 7% false negatives with a reasonable gaze pattern and a visually completely normal field. So this is a typical learning curve, and with a little bit of practice, the patient usually gets to do it well. So this was an 82-year-old lady who presented with intraocular pressures of 22 millimeters of mercury. And what we saw over there was, again, a clover leaf pattern. Disc was fairly okay. We did not expect to see this sort of a defect. And the reason we saw this sort of a defect here was because she was 82 with a foveal threshold of 37 decibels. So now what happened here is at an age of 82, you don't expect to see a foveal threshold of 37. The machine calculates some of the thresholds based on the foveal threshold. And this patient was basically tested at a much higher visual hill of vision than was normal for this patient. And that's why she's showing up all these defects in the periphery. The converse of the clover leaf is something which we call a lower threshold artifacts at the onset of perimetry, causing this artifact. This is something we described a few years back. And this is somebody who has not understood the test right at the beginning. So not paid very much attention when the first 4 points were tested, but then figured it out and has done a fairly good field. And when we repeated that the next time, you can see that that's absolutely normal. And you can get sometimes all 4 points, sometimes just 3 points, and sometimes even just 2 points. So again, this just stresses how important it is that you instruct your patients how to do the visual field appropriately. Then there are a few other things that we need to be aware of, and that's anatomy related. So this is somebody with a narrow palpable fissure, and you're seeing a superior defect, or with ptosis. And once you tape that upper lid, you see a completely normal field. You do not land up that superior arcuate defect, which you saw earlier. So whenever you're looking at a visual field, look for artifacts. And this is the one situation where the grayscale is helpful. You also need to make sure that the perimetrist understands the implications of each of the steps while administering a visual field and while monitoring a visual field. It also helps to explain to the patient how the test is done a little bit so that they can also pay attention and do the test appropriately. And of course, don't forget that if you have a doubt, it's much easier to repeat the test than try and interpret a poorly done visual field. Thank you.
Thank you very much. That was very interesting. I wasn't aware of the reverse cloverleaf. I've not heard of that before. So that was really interesting for me to find out about that. And also, I was glad you emphasized the idea of learning with visual fields, because it's a subjective test. There's an element of patient learning for the test. So that was really interesting. Thank you very much.
Yes.
Any more comments from the panel before we move on to Dr. Parul?
There are two questions, I think, to Dr. Ronnie.
Okay.
The first one is, how reliable using the crystal liquid lens designed in Zeiss's visual field machine?
Yeah, it's good to use. It's fairly reasonable within a certain range of refractive errors, but it's much more expensive.
Okay. The other one is from Dr. Iyad Armoush, is, should we put the near correction for the patient or adjust it full near art?
Yeah, so what you need to do is you need to basically put in the patient's refractive correction into the machine itself, and the machine will tell you what lens you need to put in. And the ball is at 30 centimeter distance, so you would actually need to correct for near. But you don't need to figure this out on your own. The instrument itself will tell you what to do.
So you just enter the distance correction and then the machine works out the additional, is that correct?
Yes, that is right.
Thank you. Thank you. So now we have Dr. Parul, who's going to talk about what's new in visual fields, which is quite a hard talk to do, I would have thought.
Well, thank you, Dr. Bacon, and here we go. So I'll be talking about what's new in visual field testing. Across the globe, Humphrey Field Analyzer continues to remain as one of the mainstream field detecting tool. They have come a long way from the original model way back from 1984, which had a very large footprint, to the newer version, the Humphrey Field Analyzer 3, moved from metallic rimmed lenses to liquid lens technology. And it's just not been the changes in the hardware, they have made changes in the software. As research has poured in, and it has shown that macular changes happen even in early glaucoma, so it was realized that we need to add points to ascertain the changes that are happening in the 10-2, even at an earlier stage. So some optimum test points have been added from the 10-2 pattern to the 24-2 pattern, additional 10 points, which you can see on the right-hand side of the screen. And on using these new protocol of CETA Faster 24-C, we can see that on the left-hand side, when the patient underwent a CETA standard, there were no paracentral scotomas, which became visible only after the CETA Faster 24-2C test. So although there have been 10 points which have been added, it's still quite fast. It's 30% faster than CETA Fast. Clinically equivalent to both CETA Fast and standard, uses the same algorithm and normative database, and it removes the unnecessary dead time during the test. So earlier what used to happen, there used to be a delay of about 300 milliseconds after each non-responsive stimulus before a new stimulus was shown. So that redundant time has now been taken care of. No blind spots or false negatives are tested. That again makes it faster. But there is a provision in the software that if the clinician wants to check out false negatives, that can be done. The fact that all these tests are clinically equivalent, it allows for a mixed CETA GPA report, which is a very wonderful thing to have. The conventional perimetry also expects the patient to keep looking at the center, to keep fixating throughout the test duration so that there are no drifts and the same retinal location can be tested throughout while the thresholding is happening. Even a small fixation drift, as we have seen in the previous slide, even a small fixation drift can cause large test-retest variability. Now, this has been addressed by fundus tracked perimetry, also called as microperimetry, in which there is a live tracking on the retina and there is an adjustment of the stimuli projection. And the microperimetry not only identifies the areas which have been identified by SAP, but it also gives information regarding additional areas of loss. Now, the previous versions of microperimetry, the MP1, the MAIA, they were mainly focused on macula. But now we have a new microperimeter, which is the COMPAS, which can perform 24-2 fields, and it incorporates the SAP testing strategies. It makes use of the ZEST algorithm, which makes the testing quite fast. And the color images of the fundus and the optic nerve can be mapped to the final perimetric result. So in this way, we can have the structure and function analysis in one go. On comparison of the COMPAS microperimeter with the Humphrey field analyzer, it has been found that both of them have almost similar diagnostic precision, but the test-retest variability of the COMPAS is better than the Humphrey field analyzer. So this is something which is promising and needs to make way into our practices. Another thing is that it was believed that the magnocellular pathway is affected earlier in the course of glaucoma. Although the newer histochemical studies and the newer psychophysical studies have shown that, all the pathways, be it M cell, P cell, or K cell, are almost equivalently damaged throughout the course of disease. But that doesn't take away from the credibility of the data that we have received using the flicker perimetry. Now, flicker perimetry in one version was being used in FTT, wherein there were gratings that were flickering at a certain rate. This now has been redefined as flicker defined form, wherein there are targets in black and white in two opposite phases of background and the target, and they flicker at the same time. And the patient observe this as an illusionary edge. There is a dark gray ring which pops up against a gray background. So this is actually targeting at M cells. This test allows for less test-retest variability, and it has overcome the main issue of FDT and even swap, which meant that there was, the blur and the media opacities were majorly influenced the outcome. That has been taken care by the flicker perimetry. So OCTOPUS, twin field and edge perimeters by the Heidelberg, all three of them, they all perform SAP and FDF. So you have the option of using both. The Heidelberg option also gives you an HRT and an edge perimeter in a single printout, so you can analyze its structure and function together. Now, when we have so much of options, we have to think that we have to categorize apples and apples and oranges in the correct manner. That just doesn't mean that you can use these tests interchangeably, because each of them is having a different testing algorithm, a different trend analysis software. They have similar levels of sensitivity and specificity, but still the data cannot be used interchangeably. The OCTOPUS, in addition, just like the COMPAS, has a polar analysis software in which, again, we can superimpose the visual field data on an optic nerve image and we can get an idea of structure and function. This is one of my studies which I've done with the Heidelberg edge perimeter, and herein we compared the edge perimeter with the standard Humphrey field analyzer version 2 and the HRT, and we found that the flicker defined form perimeter, the mean deviation, correlated very well with the mean deviation of the standard perimetry and almost all parameters of the HRT. But the pattern standard deviation somehow of flicker defined form did not correlate well. So we just suggest that Heidelberg edge perimeter is good for early detection, but not for moderate and advanced glaucomas, because as the depth of the defect becomes deeper and the pattern standard deviation starts getting defected, the results get erroneous. Another new thing, which is now becoming even more relevant in COVID times, is tablet-based perimetry. So one of the first free versions of a tablet-based perimetry was Visual Fields Easy, which is available on an iOS platform and can be used only on an iPad. It was developed by Dr. George Kong, who's a glaucomatologist himself from Australia. And this test uses 96 test locations, checks central 30 degrees, and uses a size 5 target. This is how the test looks at on an iPad. That's how the printout looks at. We get false positives, false negatives, but we don't get any mean deviation and pattern standard deviation. So that's one of the problems with Visual Field Easy, that there is no comparison between Visual Field Easy and the standard achromatic perimetry. It was used in community setting for testing, for screening of patients for glaucoma. So this study was done in Nepal, and it found out that this VFE was good for picking up moderate and severe patients of glaucoma. It could not pick up patients with early changes. However, I would still say that it is better to pick up something than to trash this technology. So even if it's missing some early defects, it is actually picking up moderate to advanced defects. So for in low resource settings, you're just having to spend a cost of an iPad, and this version of Visual Field Easy is free and it can be used as a reliable perimeter. So we used Visual Fields Easy for glaucoma screening in our North Indian population, and this was done in certain camps. And we also found the same result, that the early glaucoma was missed, and the sensitivity and specificity of this app for detecting moderate and severe glaucoma was good enough. So on the bottom right, you can see there's a parser code which we get from the developer of the app, and each test has to be fed into the parser code, and we get a number of missed points in each test. So the data was analyzed based on number of missed points for each test. Then from the same developer, we now have Melbourne Rapid Fields test, which gives the outcome in a very similar fashion to the standard achromatic perimetry. So you have a mean deviation, a pattern standard deviation, false positive, false negative. So that's something which we are used to seeing, and it's easy to correlate. It has 4 modules for screening, full field testing, central and macular testing for our advanced patients. If you look at the extreme left, there's a red cross, which is the fixation point, and white is the target. The next slide shows the front panel of the app, and then that's me doing the test. I believe that whenever we suggest any test to any patient, it's important that we do the test ourselves, that we know what we are, what the patient is getting into. Since the iPad screens can be of variable size, so we have to move the fixation at 4 corners of the iPad screen so that the entire 30-degree area is covered. So the studies on the Melbourne rapid fields and its comparison with Humphrey field analyzer have shown that it has a very strong correlation with Humphrey field analyzer, strong repeatability, and similar tests compared to CTEC. It's quite a handy tool during COVID times because the company has launched a PC version. So the patient can undertake a test on their home PC. So as you can see, this test was taken by one of my patients today itself. So it's done at a home PC at a 33 centimeter thing. So it's better than not getting any test done. So in COVID time, this has come in real handy. Then we have virtual perimetry using head-mounted perimeters. The advantage is the patient can be tested in any position, and it's good for patients with physical incompatibilities. Since there is a full coverage of the eyes, testing can be done in any lighting condition. And this is a list of a few virtual perimeters that have been developed by some wise colleagues of ours. And from India, we have two head-mounted perimeters. One of them is Periscreener and the other is C3FA. The early studies of both these devices have shown promising results, and long-term results are still awaited. And I hope this becomes a valid option for screening in public. Another interesting virtual perimeter is the N-goggle, which is a VR goggle with embedded dry EEG sensors. It uses EOG for fixation monitoring, and the output is in the form of multifocal steady-state VEP signals. And the field of view using this is divided into 20 sectors, and there is flickering happening at a specific frequency in all these 20 sectors, which is picked up by the computer. And although it has not been used very widely, it can broadly distinguish glaucomatous optic neuropathy from normal, and it has been suggested as a home-based test in future. Things which are in infancy and are taking baby steps to develop. One of them is rare bit perimetry. It has been there for a while, but still it's taking time to develop. So herein there are 30 small circular areas within the central 30 degrees where the minimal stimulus in form of 2 dots or rare bits is shown. So for each circle, the stimulus of 2 dots is shown 5 times. And the response is recorded as whether the dots were seen, whether the patient could see only 1 dot or 2 dots. So it's a hit and miss response and not a response inversion of sensitivities. It stimulates the parvocellular layers, and till now the studies have shown promising results in children. Since it's a hit and miss response, it's easy to interpret for children. So hopefully the future version of rare bit perimetry can help for visual field monitoring in children with glaucoma. Another functional test is pattern noise. This test has been developed for low resource setting areas or countries where the peripheral primary and secondary healthcare centers don't have the bulky perimetry machines. So all you need is a laptop, a chin rest, a magnifying glass, and a mouse to record the motor response. The software is free. In this, the stimuli is presented in 54 locations, just like the standard achromatic perimetry. The contrast level between the pixels is measured, and each target can have 63 different contrast levels. So from center to periphery, as we go, the density of the pixels, it reduces. And this is the outcome, how it appears on the visual field printout. It's still in very early stages. The pano has been shown to recognize glaucomatous optic field effects, which corroborate with the morphological appearance of the disc. So it's very early, but it's a promising tool in the countries where we are lacking in resources. Another perimetry is flicker pupil perimetry, but the disadvantage with this is that it detects only large visual field effects. It's complex, time consuming, and has poor spatial resolution, and hence has been almost become redundant despite the fact that it was just recently detected. So to conclude, I would say that whatever is new, we have to use it with a tinge of caution until there is sufficient evidence. The tablet perimetry and the VR-based perimetry is quite appealing, quite promising, with results almost similar to the standard achromatic perimetry. And it has an immense potential for teleglaucoma, more so in the current situation. And in future, it seems that the glaucoma diagnosis and follow-up is just a click away. Thank you.
Thank you, Dr. Barrow, for this nice presentation.
Thank you.
Yeah. One question, Dr. Barrow. This is now for this new 24-2C. Every time when we see any visual field, we concentration there is visual field defect in the central that we cannot see in the 24-2, the normal, or the old one, the CETA standard. But this is with this CETA faster. This is shorter time, and we testing more point. Are you believe this will be more reliable for the other point at the periphery?
Not at the periphery, because the points that have been added are in the center. So what I believe that a lot of cases that we were putting as pre-perimetric glaucoma will now be, we will be able to detect via the perimetry. So we don't really have to stick to the age-old notion that 30% or 40% fibers have to be damaged to be picked up on perimetry. Now with these 10 additional points, we can pick up a lot of our patients at a much earlier stage. So, but it wouldn't really influence the peripheral points.
That means if we depend on the 24-2C as a standard, perhaps we will miss an earlier visual field defect that can we discover in the other area, in the 24, from 10 to 24 degrees.
The points are the same. So the likelihood of missing out other visual field defects is not there. The only drawback with the CETA Faster 24-2C is that it is available only with the newer machine, the Humphrey Field Analyzer 3. So even if we have the Field Analyzer 752 model or any other model from the version 2, this software application is not available.
I think the point that Dr. Ali is trying to make is because it's using the faster protocol instead of the standard, you might actually miss a few defects more than you will with the standard. Am I correct?
The faster protocol is because it is leaving out certain steps. The redundant delay that was happening after a missed point is taken care of. There is no blind spot tracking that is taken care of. The false negative marking is taken care of. So when you remove these extra testing situations, you are gaining a little bit of time. That is why the test is becoming faster. It's not at the cost of leaving a lot of points.
It's not, it's the thresholding is not done to the same degree that is done with standard.
Yeah, that is true, sir.
So,
I mean, it's not using the 4x2 thresholding technique, but it's an intelligent software which is sort of compensating for the things that it is leaving out.
Not absolutely. The same argument happened when we moved from threshold to CETA standard also. So you would expect to see slightly fewer, you may miss a few more defects with CETA Faster, but the trade-off is that you're going to pick up more central defects without doing a 10-2. Okay. So I think that's something that we should keep in mind.
Yeah. Any more questions?
Dr. Hassan, we can't hear you, Dr. Hassan. We can't hear you.
You're muted, Dr. Hassan.
Okay. Okay. Regarding to 24-2C, I think it is important in case of detecting an early changes in glaucoma. But I think in the presence of the OCT, when you are doing the OCT for the patient and macular OCT, I think it's better to combine the glaucoma workup, the OCT, with the CETA standard as its. I think by combination, it will be more accurate. 24-2 CETA standard with OCT. I think it's better than doing the CETA fast 24-2 central. As the central is just to detect the early changes in glaucoma, but when you are doing the OCT, the macro OCT, you will see the changes in the macula. As the early glaucoma affecting the ganglion cells, which is high density in the macula. That's what I mean to say CETA standard, I think in combination with OCT is better than doing the CETA fast 24-2 central.
It's valid if we don't have the machine with the new Humphrey machine. But if you have the new Humphrey machine, it's better that we do this as well as an OCT. So maybe we'll be having a different perspective of structure function correlation. So we can probably compare CETA faster 24-2C with OCT vis-a-vis, versus the CETA standard with the OCT. So maybe, I mean, it's too early.
Because I read a lot of published.
Whether
I read a lot of published studies regarding to detection of the early glaucoma as it's affecting the ganglion cells in the central of the macula, which is the density is high. They found that that's 10-2, when you are doing 10-2 program to detecting the early glaucoma before the era of the OCT. But once you have the OCT and you can see the structure of the macular OCT, you can see if there's any defect. At that time, you can shift to do the 10-2 or the 24-2 central. That's what I mean.
I think what's really good is both modalities are very complementary, and you can use both sort of in parallel. But I think what was really interesting, what Dr. Powell was saying, is that patients we previously categorized as pre-perimetric now, I suspect, will have defects which you can then see and track and monitor,
exactly,
as well as using your OCT, together. I think that's really interesting.
Dr. Rani, are you using the 24-2C protocol in your practice?
For established patients who I have follow-up on, I definitely use the 24-2C, but we were doing a lot of 10-2s previously.
Correct.
So for me, if I see somebody with a really suspicious disc and I see a normal field, I'll still do a 10-2.
I have already the 24-2 central. I have it. But actually, I don't use it because always my workup for glaucoma is OCT together with visual field and fundus photo and doing the pachymetry. This is my glaucoma workup for all my patients. So I compare the OCT with the CETA standard. I don't depend only on the central 24-2 Humphrey sub automated perimetry.
That's good. Dr. Bassel, did you have a few slides to share with us as well, Dr. Bassel?
Yes, why not? Just
that would be
one
interesting
bit
to see
about
some of your slides.
the CETA faster and CETA faster C, and maybe Dr. Hassan have young patients. The advantage of CETA faster is it's faster. It's the name of it, and
but it is not. It's CETA standard. It takes about 4 minutes in normal. This is published in normal people, and it takes CETA standard 8 minutes in glaucoma patient. The CETA fast, it takes about 3 minutes in normal. However, it takes 6 minutes, only 2 minutes between but the sensitivity of the CETA standard is 95%, and that is 93%. So it's lower than the CETA standard.
Yeah, I agree. I totally agree. But when we bought the device, we used OCTOPUS first, and then we bought the Humphrey. So we tested a little bit with a test period, and we tested with all algorithms, standard, fast, and faster C, because there is difference. So I think in our patient, because in Europe they are a little bit elderly than other in the Middle East, so it was easier with this CETA faster and more reliable test. You need to have a reliable test in the end of the day. You don't just I have a CETA standard. It's the standard, but you have to have a reliable test. This is what I want just to emphasize. Yes, I can share my screen now if no one have no other comments. Can you see it?
Yeah, we can see it.
Yes. Thanks so much for this, allowed me for these two cases in this very nice course. My name is Basil Kadura. I'm a glaucoma specialist at Huddinge Valley Hospital in Sweden. I'd like to present two cases. The first one about 80-year-old white male with ocular hypertension in the right eye and PUAG in the left eye. He's taking a combination of beta blocker and carbonic anhydrase inhibitor in both eyes and prostaglandin analogs in the left eye. We did SLT both eyes for 5 years ago without any effect, and came to meet with failed trab in the left eye. That trab was done 2003. You can see the IOP is 18 in the right eye, 20 in the left eye, and the max pressure was 26/39. He has fairly normal thickness, and the CD ratio right eye 0.75, in the left more advanced 0.9. You can see here, I'm just showing this case because maybe most of us are used to analyze the Humphrey system, but we used to the OCTOPUS system, which is also good, I think. So you can see here in the, this is the right eye. This is a series of visual field over 5 years. And you see maybe here it's coming a little bit defects here, maybe a little bit nasal step, but it's fairly high false positive, so it's variating. And the left eye, it's becoming worse in the upper visual field. So when we look at the trend analysis in the left eye, we can see that it's going down over 5 years. But if we take the last 3 examinations, we can see that the worsening is about 5 decibel per year, very fast progressing. The right eye over the 5 year, it's possible it's progressing. It's not, you know, the device wasn't sure, and it's maybe stable because 0.4, you know, it's nothing maybe. So the last 3 examinations, you can see that it's stable with the trend analysis. So may I ask the panelists, do you want to look at other things here in this visual field? Any other analysis you want to look at?
Yes. We see the central
especially the right eye. The left eye, maybe we have confirmed it, but the right eye, is it worsening? Is it stable? You know. I'm coming to. We don't have so much OCT. We have just 2 examinations. We depended on the visual field in this patient for some reason. So I mean, in the visual field, do you want to look at other things, other type of analysis? Okay, here we can see the OCTOPUS event-based analysis. You can see here in the left eye, it is getting worse the last 3 examination here in the upper visual field. This is the visual field view, it's not the retina view. So we are sure that this central cluster is getting much worse, which is very important for the patient reading, and it's getting worse. So we are sure of it. But in the right eye, where we wasn't sure with the trend-based analysis, we can see that those temporal clusters, which are typical for glaucoma, are getting worse, especially the inferior one. And Dr. Ali Sheikh asked for OCT nerve fiber layer. Here we have just 2 examinations for some reason. And you can see that it correlates with the visual field event-based analysis. If you take the right eye, this was 2015, and 2 years later it was worsening in the upper and maybe lower, and it correlates with the lower and upper visual field. And the same thing applies to the left eye. So our plan was to that the patient should use the prostaglandin analogs even in the right eye to lower the pressure, although the pressure was 19, and I did Openzane gel stent in the upper nasal quadrant with good effects until now. So this was my first case. Do I have time to the other case?
I think Dr. Basil, if Dr. James have many cases, because we planned this Dr. James to stand. Dr. James?
It takes just 2 minutes. Dr.
Yeah,
James,
my slide is only 2 or 3 minutes. So yes, please, Dr. Basil.
Thank you so much.
Yeah, done.
So this is my second case. Also a 90-year-old white female with buag in the right eye and ocular hypertension in the left eye. She's using beta blocker just in the right eye, and we didn't do any SLT in both eyes. She came to me with eye pressure 22 in the right eye, where she's using the beta blocker, and 26 in the left eye. Max pressure is 25, 26 with fairly normal thickness. Cap to disc ratio, the right eye 0.7 and the left 0.6. Here at the visit of visual field, you can see the right eye here, maybe nasal stip with bureau defect, and it's normal in the left eye. And the pressure was 22 and 26. And she wasn't the best patient for the OCT nerve fiber layer. You can see many motion artifacts, many blinking artifacts. So we decided to depend on the visual field in these patients. She performed fairly well. So our plan here, because we saw this visual field to do SLT in the right eye, and she have to use eye drops in the left eye because we already have some defect in the visual field. So we want just to protect the other visual field. And our target pressure was 18 in the right eye, 21 in the left eye. After 1 month, it was 18, 20. We were just satisfied with this. And we planned visual field after 6 months. And because of Corona, she came about 1 year later. With just normal pressure is at the target pressure, but worsening in the right eye, it's worse. So because the patient said that she has very good compliance, and here in Sweden they call us for eye drops. When the eye drops finish it. So they have good compliance. So we believed her, and we decided just to apply the visual field. And here we did the Humphrey system. You can see maybe it's slightly difficult to compare, but the right eye, it's fairly the same with the eye pressure very accepted. But in the left eye, we saw this defect in the pattern deviation, but nothing in the total deviation. And you can see that the glaucoma hemifield test was borderline in the right eye, which is very sensitive for glaucoma, and the gaze tracking is okay. But may I ask the one panelist if you have any comment on the left eye visual field?
Yeah, so if you look at the total deviation plot in the left eye, you see that most of those points are well above threshold. You
Yes.
see +4, +6. I can't see it very clearly, but they're, so the pattern deviation plot would look at the 7th most sensitive point.
Yes.
And then recalculate the field based on that.
Yes,
So that's
exactly.
because you have a better field than what you expect. You're seeing a defect.
Exactly. We usually have this pattern, defects in pattern deviation, but not total, when the patient is a high trigger patient or happy trigger patient. But look at the false positive, it's nothing. So we have to look at other parameters. Look at this glaucoma hemifield test. We were lucky to have lectures from Anders Hill and Professor Paul Bengtsson, who developed the CETA algorithm, Swedish interactive algorithm, thresholding algorithm. So this the glaucoma hemifield field test, when it's abnormally high sensitive, it means that the best test point locations are so high as to be at levels seen in fewer than 0.5% of normal subject. So look also at the gaze tracking. So our decision was that the patient is not suitable for visual field. She's not doing well. So we decided to repeat the OCT retinal nerve fibrillary and including the GCL complex with her. So my take-home message is to look at both trend and event-based analysis when you look at deterioration of visual field. Look carefully at the sensitivity and summary values as well as other indices. And not all the patients are suitable for visual fields. Consider other follow-up methods. And for those who have very high volume with the visual fields, either the Humphrey system or OCTOPUS system, I have no financial interest, but you can download these books from the official website for free PDF version. And thank you so much for your time.
Yeah, thank you, Dr. Basil. Please, Dr. James, can you share your screen?
Yes, I will do that. Thank you very much. Also, just to let you know, we have a 20-minute extension for the presentation today, so we have plenty of time to discuss things after my brief few clinical slides. Just so you guys know. Okay, so I will try and present my screen. Okay. Can you see my slides now?
Yeah.
Great. Okay, great. Thank you very much. So it's been an excellent seminar this evening. Thank you very much, everyone. It's really interesting hearing the talks. I've just got a few clinical slides to share with you, and then we can have a good discussion together as a panel. So thinking about visual fields, this has mainly been mentioned before. I thought I'd just show a patient with typical glaucomatous and visual field changes. And we've spoken about the detailed minutiae of patients, but I just wanted to show some of the audience maybe not quite as aware as we are about these things. So this is a patient with very typical glaucomatous and field loss. You can see it's obeying the horizontal midline very strongly. The visual field defect is starting off nasally and spreading towards the blind spot. And also to point out, particularly for the residents or junior doctors, it's important to orientate the fields so that as you look at the fields, the right visual field is on the right and the left is on the left. Because that means that you don't miss, for example, a bitemporal hemianopia or homonymous hemianopia. So it's always important to orientate the fields, as I've done here on this slide. So this is just typical glaucomatous changes in this patient. This is another patient with very early glaucomatous damage. Again, we're talking about correlation of OCT and perimetry. This patient, again, the right visual field is on the right-hand side, and it correlates well with the early glaucomatous excavation of the optic disc, which you can see here on a color photograph, and which almost we would call pre-perimetric glaucoma, but I suspect with the addition of the 24-2C, they would have more defects on their perimetry. But even on this 24-2 standard, you can see the glaucoma hemifield test is abnormal, and there is an early central or sort of nasal scotoma there, which you can see, which correlates with the structural change. This is just very early disease. Thinking about advanced disease, we've mentioned again central testing. So on the left of the screen, we've got the 24-2 visual field, which is not entirely, can everyone still hear me? Is everyone gone? Is everyone still there?
With efficacy, and this points to the method of.
Okay, so I'll just finish off. So on the, can you guys still hear me? Everyone still hear me?
Yeah, we are hearing.
Okay, good. Okay, sorry. I just heard some funny sounds. So on the left of the screen is a patient with advanced glaucoma with a 24-2 visual field, and thinking about long-term progression or long-term monitoring of the patient, that wouldn't be very useful. So the 10-2 visual field here on the right of the screen is more useful because then you can look for progression within this patient. So you have to utilize different strategies depending on the patient's disease. And even you can use, as another speaker mentioned, 10-2 for early visual field loss as well. Always be aware of atypical findings or non-glaucomatous field loss. So when you look at this visual field, you can see the defect is quite symmetrical, and also it's starting more temporally rather than nasally, and also it's quite peripheral. It doesn't look, to my mind, typically glaucomatous, although certainly you could be convinced there is some damage there with the global reduction of sensitivity of the retina, also with some sort of superior deepening of scotoma there. So always be aware of atypical findings. And indeed, this patient has got retinitis pigmentosa. So retinal disease, as well as optic nerve disease, also affects visual field testing results. So don't always assume it's always glaucoma or always an optic nerve problem. Make sure you do a dilated fundus examination and think of other disease as well causing this visual field defects. So I think just to sum up, this is probably my most important slide, really talking about risk stratification and importance of visual field testing in patients is to work out, is this a high risk or a low risk patient? And therefore, am I happy with a higher IOP or do I want to target lower IOP? So weighing up the visual field damage with a patient's life expectancy with untreated IOP or the Tmax IOP, as Dr. Bassel mentioned, as well as is it a secondary glaucoma, and also the rate of progression, thinking about progression in these patients, is it a fast or slow rate? So weigh up all these things together, and this European Glaucoma Society slide emphasise the importance of individualising patient care. So thank you very much, and that's the end of my few slides. I will now try and get back to the presentation.
Thank you.
Very nice presentation.
Yeah. One question,
okay, thank you very much. Yeah, thank you very much.
One question for this patient with advanced visual field defect on central tubal visual field. You make this is 10-2, but always you repeat the 24-2, or you make more as 30-2 to see if there is any remnant for the periphery visual field.
I think for me, I would alternate. So for me, I would keep using this 24-2 or maybe a 30-2, but I would also use a 10-2. So I'd use the two visual fields on alternate visits. Yeah. I don't know what anyone else would do.
For me, I prefer the SSL always to do the same. But here we see if we have a peripheral visual field, can try for continue with the 10-2, and can we make with the kinetic visual field if we discover any peripheral visual field defect, peripheral remnant for the visual, can we measure that onto control? As this patient with retinitis pigmentosa, this is good, the kinetic perimetry, to see any peripheral visual field. But unfortunately, I didn't have that, but as theoretically is good solution for this patient.
Yes, that's a good idea.
I think it depends on the patient's needs. Elderly patient, they want to read, they want to just can remove around. So it depends on the patient worsening. But usually we use the 10-2, and as Dr. Ali has said, we just keep with one method to compare the worsening, because you know the software nowadays they can use many algorithms at the same time, but sometimes it's difficult to compare 25 to 10-2, 24 to 10-2. Therefore, we just keep with one method when we use it.
And if you had any idea about this combination or any experience with this HOD OCT, this combination with the visual field and compare with the visual field?
Yes, the HOD report, I'll be talking about it in the third day, but we have it in our machines and we don't use it for some reason, because when we started the OCT, we started first with the retinal nerve fiber layer, and we must just create a normative database to the same patient. I mean, some patients are high myopes, some patients are high hyperopes, so we need to continue with the same method to get the trend analysis and event analysis in the OCT. And it's not feasible with the software from Topcon now, unfortunately. I mean, to compare the 3D wide, it's called the scan, with the RNFL. It's not feasible. You have to start with one method and continue with it, the same method, to enable trend and event-based analysis. So I use it sometimes in some patients when I'm in doubt or the patient can't do the visual field. I do take the Hood report. And for those, for listeners, Hood reports is a wide scan of both the optic disc and the macula. And in the optic disc, they do analysis of the nerve fiber layer, and the macula, the GCL IPL. And then they create a report where they mimic or they just flip the defects, so it's mimic the visual field view. And there are very good work of Dr. Wood and his colleagues that saying that the structure and function correlate well if we do a lot of tests, as Dr. Hassan Khalid has said. So it depends on the system, on the health system, and on the examination one is familiar with.
Jasmine, if you have any patient with suspected glaucoma and you have this thought this is perhaps a sign of visual field defect, and there is any changes in the visual field, you need to be corresponding with any change in the visual field, on OCT and visual field. You make Hood report to check on those with the Hood report, or depend on separate?
No, I take the retinal nerve fiber layer, the optic disc tube alone, 3D disc, and the GCL EPL or GCL plus in the top machine alone. And I have two screens, so I can see the trend analysis with them. As I said, technicians sometimes will take the machine, so they don't. Sometimes it will be difficult to understand which scan is needed to get the Hood report. I take it myself sometimes to guarantee it, but we just take the nerve fiber layer and the GCL EPL and continue with it. And compare it with the visual field, I mean.
Dr. Rene, Dr. Barol.
So if you have access to the forum software, which comes with the Zeiss system, you can actually create a combined report which combines both the visual field and the OCT. So it overlays the OCT sort of grading onto the visual field. And that gives you a sense of what is happening. And since both use similar progression strategies, they both are labeled similarly, you can even actually compare progression on both machines in a similar fashion. And with the forum, you can even look for progression on the 10-2. You get a trend-based progression there. You don't get an event-based progression, but it will give you a trend-based progression on the 10-2, which is not available as a printout as of now. So we need to make use of whatever software is also available. It does make our life a little easier.
Would also like to use macular testing in cases with advanced glaucoma, because it is looking very focally at the central 5 degrees of the field. So in one of the last few slides, which Dr. James had shown, the advanced visual field defects, where even the 10-2 is almost knocked over, they're having a closer peak at the central 5 degrees also helps sometimes. So a lot of times I alternate between a 10-2 and a macular test, especially for the advanced cases.
So, Dr. Parul, is that with the size 3 or a size 5?
It's with the size 3, don't really alternate too much with the size. And cases which are totally knocked off but are still retaining good vision, then they have tried size 5. But size 3 still gives a good idea of what is happening.
But what would happen is that if you're doing it with a size 3, you are checking the same points on the central 5 that you do on the 10-2.
What my experience has been, the size 5 test, somehow it says that the target is visible, but the output somehow looks very haywire. So the correlation aspect of it becomes difficult. And a lot of times, since the technicians are doing the test, they sometimes do once with the size 5 target and the next time with the size 3. So I have preferred to stick to size 3 target. It gives an idea broadly as to the changes that are happening in the center. Maybe it's the same thing, but it's been blown out in a way that I can concentrate more on the changes in the decibel level that is happening at each point just surrounding the fixation. With the 5 and 3, I've tried that earlier, but a lot of times the output has not been as I thought would look like.
Yeah, usually in patient with still have vision, and after doing the visual field, there is perimetric blindness in this patient. I prefer to tend to see the macular split, and also I prefer also to use the target 5 to see the tubular vision for this patient. Some patient may have a remnant tubular vision. When they ask the patient, he can see, but when you do for him the visual field, the test is reliable, but it's perimetric blindness. Also, it's not recommended to do OCT in advanced glaucoma because you know that the retinal fiber layer thickness will fix it at the level of 40, 50 micron, will not decrease less than 40 or 50.
This is depend on the machine. This is for the Zeiss around 50, for the OptiView around more than 60. The floor effect.
Yeah. But I think I agree with Dr. Hassan's point that if you've got very advanced glaucoma, I find OCT pretty useless. And that's when I switch more to the visual field.
Exactly.
Yeah, I mean, I strongly agree with that.
May I ask you, panelists, a lot of studies have been published to show that the GCC, the ganglion cell IPL, is useful in the advanced glaucoma. I myself haven't found that because most of my patients already have AMD maybe with the glaucoma, so it's worsening anyhow. But anyone have some practice or some experience with this?
I suppose it's similar to what we do with the 10-2 because you are looking at the central field which is preserved till the end. And with the GCC that you see, you are actually somewhere 5 to 7 degrees of the field is what you get. You don't really get the complete 10 degrees. So from that perspective, it helps. And you do see correspondence between the macular program and the 10-2 if you combine the both on the forum software. So only from that point. If you're following up the central field, you could probably look at the macular too, but I would still prefer to follow them up with the visual field because ultimately you're worried about function in these patients more than the structural change.
Yes.
Would you change your therapy based upon the change in the macular OCT parameters? The fields sort of appearing the same, but would the OCT change tilt your decision towards aggravating the therapy?
Not based only on the OCT, no. But if there is something else clinically which is contributing, I might decide to change, but not only on the OCT.
But at least can we shorter the follow-up? And this is depend if there any change. And this is, I try with many machines for the ganglion cell, the central ganglion cell, no financial interest, but I found this is for the OptiView, the ganglion cell, the central ganglion cell, the follow-up is very beautiful. When for this machine, you compare the optic nerve, the nerve fiber layer, and also the GBA for the ganglion cell. When you find any change on this increase this changes gradually, you should find any changes in the visual field. On this patient, when you repeat on, or you find this is 24-2 as normal on MEG 10-2, you find there is small changes in the visual field. For that, with this machine, I found there is good correlation between the visual field and the ganglion cell.
Yes, as Dr. Ronnie has said, it's very controversial to just treat depending on the OCT. But I do use the slide that Dr. James Bacon has showed, which the European guidelines with risk factors, especially if the other eye is already, you know, very glaucoma in the other eye, or there's a very high or positive family history, or you know the other risk factors, very thin cornea, hysteresis. So, and if the patient can't do well with the visual field, I do then depend on the OCT. Otherwise, it's the visual field.
Unfortunately, here we depend on the objective more than subjective, because many of the patients, when you ask about the family history, is negative. And if you ask many things about the risk factor, you find this is also negative. This is the problem. دكتور محمد العمري معك قبل.
مساء الخير دكتور، كيف الحال؟ شو اخباركم؟
اهلا دكتور محمد.
Good evening to all. دكتور بارل، دكتور روني، دكتور حسان, everyone.
Good evening.
Dr. James.
Hello,
thank
nice
you very much. Maybe we are exceeding the time. If we can just do within 2 minutes conclude, if you don't mind.
Yeah,
no problem.
Okay.
Okay, Dr. Ali, شكرا جزيلا. Thanks for all of you. Thank you.
Thank you. I have only one question by the end of this nice session out of the visual field. The question for Dr. Basil, he present the first case that patient put on the prostaglandin on one eye. For me, I don't recommend to put my patients on prostaglandin for one eye. Always I prefer to put in both eyes. I want to hear the opinion of Dr. Basil and also the opinion of the panelist, please.
Yeah, sure. With the redness or pectopathy and other sides, but sometimes you know, one starts we treat patients with referrals among others. So one starts the patient with combination, and another doctor sees the patient and put eye drops to lower the pressure. So here, you know, we do just inform the patient about the side effects of the medication, and they do tolerate them. You know, if redness comes and the patient and the eye pressure is all right, the patient may continue with the therapy. So, you know, it differs from a country to another country, I think.
Yeah. No, this is the problem, Dr. Basil, is with this is long lashes on the hyperpigmentation around the eye. This is the problem.
Cosmetic.
It's very, I think this is in this last 6 months, 2 cases after not more than 6 months, one young patient after 2 months, this is very long lashes and with hyperpigmentation around the eye. That is this. This is to be trouble and to be careful, because that's the people.
We are aware of we know here in Sweden they have the patient himself can go to a website with all the possible side effects, and they are aware of them, and they have this and they accept it. So as I said, different from one culture to the other. But having said that, to just summarize, maybe we're going to operate the other eye soon as well. So
my point here, if the patient is using anti-glaucoma for both eyes, and one eye is prostaglandin, other eye is beta blockers, or combination between the beta blockers and carbonic anhydrase inhibitors. So for like this case, I prefer to use prostaglandin on both eyes and change the combination to, for example, only beta blocker or carbonic anhydrase inhibitors, and follow up this patient. That's what I prefer to do.
Yeah, this is what I did.
And thank you for this nice session. Thank you, Dr. Ali. Thank you, Dr. Roni. Thank you, Dr. Barol and Dr. James. Thank you so much.
Very nice to meet you all. Very nice to meet you all.
Yeah, thank you all.
Thank you. Bye-bye. Have a nice evening.
Okay.
Yeah. Ma's salama. Take care.
Okay. Okay. Bye-bye. Bye-bye.
Most of them tomorrow, inshallah.
Okay. Bye-bye.
Most of them tomorrow and after tomorrow, inshallah.
Yeah, good.
Bye bye.
Thank you. Thank you.
Thank you. Thank you.